Welcome back, everyone. This is week 4 of GME 162. Let's finish the this week off with chapter 6. We're going to discuss the rest of EDMI, and then we'll get into what's coming up for the labs. So, what I put on the YouTube channel, and I need this to go away. Come on, go away. Let's see where we at here. I have a couple calibration stuff there for you guys too, but that's for later. So I have a couple more videos on the elementary surveying, chapter 6. We have random errors and we have the instrument reflector offsets. Those are pretty great discussions because they keep it pretty simple and just give you a easy explanation of using the equations 3.11 and as well as the other equation for establishing your reflector offsets, or giving you the K value is what it's called on a prism constant. We don't, for lab purposes, we're not going to really have to figure out what K value is, because the fact is that we're going to end up having the given values on our prism offsets when we get into that. So you will see in the video, they're going to talk about these shorten and long wavelengths that run from the EDMI to your prism or your reflector, and then they come back, the return energy, and then give you, that's how you are carrying out your distances and your angles, mainly your distances, because angles can just be calculated when you set your total station to 0, especially those top guns that we use. You will see that they discuss random and systematic errors in the video. And again, they will give you we already discussed systematic errors in the previous one, but the random errors will be carried out in that video. You will see this formula. This is the formula based off of equation 3.11. That's also in the chapter book of Pearson. They're going to give you error of D as your total distance. Then you have I, which is error of instrument centering. R is reflective, and C is a constant, and C is the standard scalar error of the instrument. Usually those are in a manual like this one, which I will also upload to Canvas, and you guys can look through. It's actually a pretty good manual that gives you a lot of different values and information about those top cons. Pretty easy read as well. Not easy read. Just pretty easy to find the information. It's a boring read. Obviously, it's just a manual. But what I like about these things is that they just give you, your prism systems, your error displays, anything like that. Even just how to just set up and adjust, make all your little adjustments that you need to do if you needed to do those. But again, very basic stuff that we're working with when it comes to this lab. So again, you will see those equations posted on that Pearson chapter 6 video. The other part that they will also talk about is the instrument. These are the personal limitations. So this is how well you can, the I-man or the instrument person can set up over a point on point A, and R is the broad man, how well they can center their prism on the point B. And then again, these values are given to you in any type of situation. So a quick example that we would work with is this. Let's say you got a distance of 23,068.25. The standard error is plus or minus, you have 7 millimeters plus 7 parts per million. The centering error is 7 thousandths, and the target, so this is I here, and then the target error, which is R, is 16 thousandths. And then we're trying to figure out what the standard error of the observation is. So if we go real quick through all this, we go, okay, so we got I is 7 thousandths, R is 16 thousandths. Where are we going? Hang on. There we go. The centering is going to be that 7,000, and it's going to need to be converted over to millimeters, right? The 7,000 meters, and 7,000 meters, or that's one extra zero in there. That needs to be like that. So you're going to have to convert that over to millimeters, or to feet, sorry. And that's going to be from centering, that's going to be that 7 thousandths of a meter converted over to feet. It's going to be 23 thousandths of a foot. And then we go over here, change this to our standard scalar. We have to convert that from parts per million. So we go 7 divided by 1 million times our distance, and we get that 16 thousandths. So now we take those values in feet, right? We're going to go, all right, so we got 7 thousandths of a foot squared. We have 16 thousandths of a foot squared. And these are added, summation, 23,000 squared. And then again, our standard scalar error, 16,000 squared, all over the square root. Our error of the distance is plus or minus basically 300ths of a foot. And then 300ths of a foot over 23,061.25. Well, if you would take it on a calculator and you go the same thing and you go that 0.033 divided by that distance of, let's just go divide here. 2368.25 divided. All right, well, what's that? That's in decimal. So let's put that as a fraction. So for one part measured, that's per 71,000 parts per, or the ratio of 1 over 71,000. That's actually really good, over that distance. The next part you'll see in the video that's discussed, and actually this was already discussed in the systematic errors, is from the EDMI. You have the A value that hits the from EDMI, and then you have your to EDMI, that's C, B being the center of the prism, D being the width of the prism, and then K being where the sunlight, the effective center, would run through and hit. And so again, if you were to go through that video and watch it, you were going to get that the formula of AC plus K equals AB plus K, and then that's plus BC plus K. And if you were trying to find the value of K and rearrange that with the algebra, you go AC minus AB minus AC. K in that, with that formula in regards, usually ends up being a negative value. But depending on the prism offset that you have, you might want to be, changing that to a positive value. The other part that you'll see in the video for that, the systematic and the personal, is temperature and atmospheric conditions. So you always want to understand, that heat and cold are always going to be, especially when it comes to long sight distances, you're going to have to make sure that you are inputting those in, whether you have using the total station itself, inputting into the total station itself. In my office, we do it on the data collector. So the data collector, talking, radio frequency with a total station, makes those adjustments and makes those corrections when we're taking measurements, especially anything over, especially anything over 400 to 500 feet. That becomes the big issue with that. Moving on to real quick, let's see the lab that's coming up. I'm going to sound like I'm beating a dead horse here, but we're going to keep going with the leveling. So I know you guys got introduced to differential leveling. You did profile leveling, and I think you guys did 3-wire leveling. Now we're going to move on to digital leveling. And this is kind of what we use now in the profession, because the random errors kind of die down with digital leveling. If you're not, the biggest thing, if you're not, actually leveled your digital level, and actually this needs to be not log, digital rod. Digital rod there. So again, we're going to do the same sequence that we did with differential leveling, with the automatic level. You guys did your peg test. All right, you figured out, you calibrated the digital or the automatic level with the peg test. And then you went through these benchmarks. Where are they? Differential level. Oh, there you go. Benchmarks on page 4. You went through Walker, Ortec, Melva, and Duryea. Then and again, starting out Ager, and you return back to Ager. Your field notes are going to be set up the same, except everything that you're doing on your field book is going to be just all your data you're collecting is from the digital level reading, rather than just you taking the measurement by your eyesight. That'll be for Tuesday. I'm going to talk to Evan about Thursday's lab, because I think Thursday's lab, because this lab shouldn't take you guys, both days. It should probably just take you that Tuesday lab. and then I'll talk to Evan about getting into starting the total stations and working on the EDMI baseline calibration. And then I'll post another video for you guys before then about if it sounds feasible. And I already kind of talked to reached out to him and see if we can discuss doing a lab off campus. And I mean, just it's still in a controlled environment, and it's just basically calibrating your total stations for those labs. If you guys have any questions, just let me know. Again, reach out, and I'd be happy to help with anything. But again, watch those other two videos that I have posted on there, especially, we started here with this basic EDMI basics. We went to systematic errors. I got to rename that. And that's got to be the new one is random errors. And then we have the reflector offset, which are great discussions and keep it very simplistic of everything that you guys are trying to understand when it comes to these total stations. One great thing that Professor Walker always said, we're not here to be button pushers. We're here to understand the actual technique of these instruments. So whenever if anything goes wrong with these instruments, we have an idea of how to fix it. Or even if you don't become a surveyor yourself and you just want to go into the profession of working with these instruments, of fixing them and calibrating them, well, then you start getting a really basic understanding with, just at first working with the total station, and then, doing the troubleshooting part of it, and then getting into the repairing side of it. So, I mean, that's this discussion for this first part of week 4. We'll get into more of the total station side, and that's going to be, I believe, chapter 9. For a lot of you guys, that's going to be just another review, especially with compass rule adjustments and traversing and all that good stuff. But again, it's very important in the world of land surveying to be, well versed in traversing and being able to set up your instruments physically, and then being able to calculate everything. All right, guys. So look for more videos this upcoming week, and then we will go from there. Thanks.